So in this presentation, we are going to talk about different set of APIs and the event codes supported by input subsystem of Linux kernel. So basically, as you mentioned earlier, like from our driver, we have to create one event and we have to pass that event to the event layer of our input subsystem. Okay. So for making this process very simple and state or making it more generic, so Linux kernel defined different types of events as well as different type of event codes. Okay, so what does event type specify? So event type basically specify the type of event your driver is going to generate. Okay, so let's say these are the different sets of event defined here. So we have event sync. Event sync is the event for syncing between two event. Let's say for the very first time you have sent some event to the user space, and now you will send event sync, and then again you will send new event. So event sync is between two event, just to specify the boundary line of one event to the other. Okay, event key is are the event which are generated by the keyboard. And then event relative, event rel means event relative, like this your driver is going to generate the relative event. Relative event means event related related to the last event. And then event abs means you are going to generate an absolute values event. So these event abs basically we use mostly in touch panels, because in touch panel we generate exact absolute x and y coordinate values. And then we have event msc, this is for like miscellaneous device. And then you have event leds for leds devices, basically you can use this. Then you have ev underscore snd for sound devices. Okay, so basically for different devices you have different types of event defined in the input event codes.h. Let's see this file actually. If you will see this file, yeah, this is the file in Linux kernel. You can find here include uapi linux input event codex.h. So here you will find all sets of events and the codes defined, so that depending upon your device you can choose the event type and event code. Okay, so if you will see here, these are the event types defined. Okay, these are the event type defined. And then you have synchronization event, like for syncing the events you have sync report, sync config, sync mount report, sync drop. So these all you can study from the kernel documentation. And then you have keys and button. Basically you have to specify, or we can say the key codes. Okay, so it's like you have to specify like what is the meaning. So why we use key codes, let's understand this first. So let's say you're writing a driver for keyboard. Okay, and in keyboard let's say you have five keys. Just for understanding, just understand you have five keys. And then you have to pass the event to the user space. Okay, by telling now key 1 is pressed, or key 3 is pressed, or key 5 is pressed. Okay, so now how your user space will differentiate which key is actually pressed. Okay, so there basically you have to define some mapping between the keys. So you will tell key 1 is denoting number 1, key 2 is denoting number 2, key 3 is denoting number 3. So this is how this mapping is created in this file, so that user space application can understand, okay, so this event belongs to this particular key. Okay, so this is the mapping here. If you will see, like for the key W number 17, key E number 18, you can see all this mapping here. Okay, and let's go down, let's see what else stuff we can read from here. Okay, so now these are the code. Okay, these are the code for like a special code for the event actually. So if you will see here, this button miscellaneous. Okay, button, for the buttons basically they have defined these numbers 0, 0, 100, like you might have multiple button in your device, embedded device. And then for mouse also you have like button mouse, button left, button right, and all these things. Then for joystick you have button joystick, button thumbs. So these all are the event codes basically. So what information you are going to pass from your driver, you are going to pass this basically the event code. Okay, so you will pass the event code, and then event value you are going to pass. Okay, so with the event code basically you are specifying this event belongs to this particular key or this particular button, and then you are pass the specify values. Okay, so here you can see the different sets of event code defined. Okay, so basically, our Linux kernel, touch panel driver, or any other input driver will work by using of these input events basically. Okay, when we will discuss about user space application, when we will have a demo of user space application, then basically we will understand this thing in detail, like how exactly this event code and value matter to us in the user space. Okay, so now with that, basically we have input dev structure which is defined by the Linux kernel. And what we do with this input dev structure, it's like in our input driver or the touch panel driver, we have to basically allocate memory for this input device structure. And this device structure you have to fill with the information like what is the name of your device, and addresses, and then input ID, and all this stuff you have to fill, and what are the values or the event codes you are going to use, event bit, key bit, relative bit, absolute bit, all these things you have to define in your input dev structure. And how it will allocate by the call input device alloc call we have from the input subsystem that we can use for allocating the memory for this particular input device structure. With that, we have input underscore event structure. So this structure is basically filled with the events. So here we are going to fill the event type, and then event code, and then event value, and this structure we are going to pass to the user space. So who will do this? This will be done by event handler layer of input subsystem. Okay, now this is something about Linux kernel input driver APIs. It's like different APIs which we use in our driver, and these APIs are basically supported by or the defined by our Linux kernel input subsystem. So the first API is input register device. So what does it will do? It will basically register your device with the input subsystem of your Linux kernel. Input unregister will do the opposite of register. It means it will unregister your device with the input subsystem of your Linux kernel. In input report select. Input report select means you are specifying an event in a specific direction, maybe in X direction, Y direction, or some other direction. Input report key, it's like you are reporting event to the input subsystem, like it's keyboard event. Okay, and then basically report ABS is like absolute coordinates, which we use in our touch panel driver. Okay, then register handler, it's like you register the handler input custom. Basically, you are registering the custom input handler in your driver. Okay, then input sync. Input sync is like syncing the event between user space and the kernel space. Okay, so these all APIs basically we use in our driver. So in the next presentation, when we will have a code walk through our driver, so you will see the uses of all these APIs.